Welcome to Integrals Applied Part 2. Okay, so here's our example or question. A stone is hurled straight up from the ground at a velocity of 25 meters per second. Find the maximum height that the stone reaches. How long does it take for the stone to hit the ground? And find the speed at which the stone hits the ground. And just to remind you of our integral format, I've included that also. Okay, so part A of the question, find the maximum height that the stone reaches. So we know that acceleration due to gravity, because the question gave us 25 meters, we know that acceleration due to gravity is equal to minus 9.8 meters per second squared, and that velocity is equal to the integral of acceleration. We know that then we can get to our velocity is equal to minus 9.8 times t meters per second squared plus c. And our plus c now is our 25 meters per second. And I really want to pay attention now because we've done a few integrals. I want to start paying attention to the units and how velocity becomes meters per second and then distance, it becomes meters. So we're going to keep all of our units really tight eye or close watch on all of our units on this in this slide. Okay, so if we want to find the maximum height, right, we need to know how much time it took to get to that height. So we know that the velocity at the maximum height is equal to 0, and now we can put 0 into this formula and solve for our time to maximum height. And again, we're watching our meters per second squared on our negative 9.8. And you can see that you can imagine that that time sitting in there is going to be in seconds and that those will cancel out. And this math here shows how we can now solve for t in terms of seconds. So if we keep the meters per second squared, we get this t equals 25 meters per second divided by 9.8 meters per second squared. And if I rewrite that as 25 divided by 9.8, I'm just trying to make it look a little bit clearer on what's happening, multiplied by the 25 meters per second. Now, because the 9.8 meters per second squared was in the denominator, we're going to invert and multiply to get that out of the denominator. So that puts the second squared in the numerator and the meter. So the meters now cancel, right? Because we're talking time. So the meters cancel. And one of the second squared cancels also. So we're left with 2.55 seconds. So that's great. We know that we've got 2.55 seconds to get to the maximum height, but that's not what the question exactly is asking. So we want to find the maximum height. So now we know what velocity is. So the integral of velocity will be our distance. Now that we've got the distance formula, we can put in the 2.55 seconds and find what the total distance is in 2.55 seconds. Okay, so here's our distance formula, and again, we're really keeping track of our units, again, because we know that distance should, after everything's factored out, we should end up with just meters. So we put our time in, and we've got 2.55 seconds to a velocity of 0, which indicates our maximum height. We started at ground level, so our c is 0. And you can see the math here. So you end up with meters in the first part of the equation, negative 9.8 times 2.55 seconds squared. So that would give you that gives you your second squared, and the second squared will cancel, leaving just meters in that first term. Same with the second term, where you've got 25 times 2.55 seconds meters per second. And so now you see the seconds in that term also cancel, leaving just meters, giving us a total distance or max height of minus 31.8623 meters plus 63.75 meters, which gives us the final answer of 31.88 meters. So the second part of the question, part B, is how long does it take for the stone to hit the ground? And if we're just thinking, well, it makes sense that if it took 2.55 seconds to get to its max height, it probably should take 2.55 seconds to get back to the ground. And that would be 2.55 seconds multiplied by 2 should give us our final answer. But if we want to do this in terms of calculus, we're going to use the distance formula and set that equal to 0. So we know we started at 0 for our c, so we've got our distance formula already defined before, and we're going to set our c to 0, and we want to know how much time it takes to get back to 0. So we're setting our distance equal to 0, and we're solving for t. And so what we end up with is a negative 9.8 t squared divided by 2 plus 25t plus 0 equals 0. And that gives us a quadratic type problem to solve for t. So the solution, we put that into, I use a TI-89. It gave me two different answers because it's a quadratic. So I've got t equals to 5.102 seconds and t equals 0 seconds. So t equals 0 seconds, that also makes sense because that's right when you're throwing the ball that you're back at 0, and then 5.102 seconds later the ball hits the ground. So our true answer is the 5.102, which is in fact the original 2.55 seconds times 2, which was where our maximum height was. So it took the same amount of time to get all the way to the maximum height as it did to get all the way back to the ground. But we were able to use our calculus formulas to show that as well. Okay, so the third part of this question, part C, is find the speed at which the stone hits the ground. So you can also imagine that the speed at which it left, all things being equal, is going to be the speed at which it, as it goes all the way up to the top, turns around, comes all the way back down, that speed velocity would be the same also. But when it goes up, it's a plus 25 meters per second, and then when it's coming down, we would guess it would be that same speed. So, but we're going to use our calculus formulas that we derived earlier to find that velocity at the time. We know that it took 5.012 seconds to get back to ground. So we want to solve for velocity now, and we put that into the formula. And we find that the answer velocity is equal to minus 25 meters per second. And that makes sense because it changed direction. That's all the minus is saying, is that we're traveling towards the origin. And we know that we hit ground level at the minus 25 meters per second. That is the final answer. That's the velocity. It is the same except for its changed directions.